Action. Hi everyone, this is Alfred from Net of Passion and welcome to the 6th live stream lecture. So the topic of today's lecture will be on mastering the probability, where I'll be focusing on a few different aspects where usually I find the students, they find it to be the most confusing. So I'll be focusing on just two main bits in probability, so namely conditional probability and also the what exactly is the random variable. Okay, so a probability, understandably, is one of the most difficult part in mathematics. Usually, students they find it, which is understandable because usually probability is very different from the usual math that many students they are used with. So usually the math that we are talking about, they are really cut and dry. So like you solve this equation, you get an answer, and then there you have it. But usually probability involves a bit of thinking because now we are talking about chances and things like this. So it's like it's things where it's like not that certain. So things like 50% chance of happening. So it's not that clear whether is it going to actually happen or so. I think that is what makes probability a bit difficult to get your head around with sometimes. Okay, so before I get started on today's lecture, so for those of you guys who are watching this right here, right now, just want to say a big thank you for your support, and this really means a lot to me. Okay, so now let's begin with the lecture. So I'll just fire up the PowerPoint slides. All right, just give me a minute. I'm gonna drag the camera down into the corner and bring the screen right here. Okay, so nice and full screen. All right. Okay, so once again, today's topic will be on mastering probability, where I'll be trying to tie up a couple of loose ends. Okay, so before I get started, so just a quick recap of what exactly is probability. So probability, to put it simply, is basically the mathematics of uncertain event. Okay, so because we live in a pretty chaotic and unpredictable world, I mean, we cannot really predict exactly what's going to happen in the future. So this is why, in order to describe that unpredictability, so we use the language of probability. Things like, there's a 50% chance that I might win and a 50% chance that I might lose, or there is a 75% chance that I might get into this school and a 25% chance that I might not get into this school, say for example. And probability to me is probably one of the most fun area in mathematics and also a really useful one. I mean, you'd be surprised in physics, you have to use probability a lot, especially when things that involve experiments. Because experiments, usually the data you get is not that predictable, so you have to use probability to analyze it. And in quantum mechanics, we use probability all the time. Now, because quantum mechanics, fundamentally everything is probabilistic, so I won't get into too much philosophical implication of probability. So I'll just focus more on the more important aspects because the year 12 exam is coming soon. So remember, in probability, we usually study like events and experiments. So whenever we do an experiment, it's going to give you like certain outcomes. Say, for example, when you flip a coin, you're going to get either head or you're going to get tail. So probability basically studies the chance of different things are happening. So what we call that, say, suppose outcome belonging to certain event A. To denote that probability with we put it into the probability function, as in the probability that A happens. Okay, so that is just a shorthand way of saying that the probability, the outcome lies in the set of A, which is the subset of the event. So we just say the probability of A happening. Okay, so in probability, there is two main components to it. The first one is to study how the different events they relate to each other. So this is why a set theory is used a lot in probability, because we talk about intersection between the sets, or like the union between the sets, or the complement of a set, so on and so forth. And of course, how to calculate probability. So which is why you learn a couple of tools under a tool block, things like tree diagrams, Karman maps, so on and so forth. Okay, so I'm assuming familiarity with all that because that one is they are pretty straightforward to understand. So today's lecture is a bit more advanced because I'll be focusing on the aspect that usually students they kind of have a tough time getting their head around, and usually students they find it a little bit more confusing. So I mean, back then when I was a student, I had a tough time with those as well. So after a long time, I think I've understand them a lot better now. So which is why in today's lecture, I just want to go through what exactly is conditional probability. Okay, so let's begin with the definition first. So say in conditional probability, usually what happens is, say you have two events, so A and B. Okay, so suppose that we know B have already happened. In other words, the outcome already belongs to B. So say for example, when you roll a dice, so say we know that it is 3, 4, 5, and 6. So we already know like the outcome. Okay, so say we know the outcome, so we have to find out what the probability of happening then. So we write it in this way. So the probability of A with a single line down and then a B. So we read this off as the probability of A happening given B have happened. Okay, so what this means is that we have a new piece of information at hand. So we know that B have already happened. Okay, so now with this new piece of information, we have to evaluate what's the probability of A happening then. So it's a kind of like you have this new piece of information. So usually that will affect whether A is going to happen or not. Let's say for example, the probability of me going for a run tomorrow, given that it will be raining. So knowing that it is raining is an additional piece of information you have at hand. So of course that will affect the chance of me, whether am I going out to run or not, which of course is going to lessen the chance that I'm going to run. Another example is say, what's the probability of rolling an odd number in the dice given that it is more than 3. So we know it must definitely be 3, 4, 5, and 6. So which means now there is a 50% chance of happening and it doesn't really affect at all. Okay, so that is what conditional probability is all about. So given a condition, what is the new probability of finding things out? So it's kind of like updating the probability of A that you are trying to find out. Okay, so how do we actually read off from the Venn diagram? And by the way, what I discussed just now is basically the definition of a conditional probability. Okay, so from the Venn diagram, how do we actually infer conditional probability from the Venn diagram? Well, actually, it's not that straightforward. Okay, so what I've written over there is basically probability of A given B have happened is nothing more than the relative area. So I'll explain a little bit what it means by relative area shortly. So the relative area of A intercept B compared to the whole area of B. So in other words, okay, so what is the area where A and B overlap each other? Because A and B must happen. Because if given B have happened, A have happened, so they both must happen together. Okay, so the relative area, it means that compared to the area B, how much area does A intercept B occupy in this in the area of B? So when you think about it, conditional probability, given that you know probability B already happened, so what we can do is we can cut out every bit, other bit of the sample space, and until we leave behind just B. Okay, so now how much overlap does the probability of A has on B, and that is basically the conditional probability. Okay, the thing is that the definition by itself is not that useful to find out what conditional probability is because it's but because you can't really tell the probability directly by looking at the Venn diagram and finding where do they overlap. So fortunately, there's a much neater way to go about doing this, and we evaluate it by this equation. So it's a very neat equation, basically saying that the probability of A given B have happened is equal to B. The probability of A intercept B is because in order for A to happen, given B have happened, of course they both must happen together. So that's a pretty obvious one. And the one at the bottom is because we already know the probability of B or the probability of B actually happening. So which is how we can factor it out and then just putting it down there because we already know that it has already happened. So it's like kind of the factoring out of the probability of B. And of course, just a word of warning, when it comes to conditional probability, is that order matters. So the probability that B given A have happened is very different than the probability of B given A have already happened. And also this final bit over here, it's kind of hard to get your head around to someone. It's kind of saying that, okay, so what's the probability of me running given it rains tomorrow, and is different from the probability of it raining tomorrow given that I ran. Definitely they are related, but they are definitely not equal. So for this, take a bit of time and think about this and convince yourself of why is that the case. Actually, you can show that they are not equal by using the equation I've shown above, which is a pretty good exercise for you to understand probability a little bit better. Okay, so the use of conditional probability allows us to establish what it means by mutually exclusive and independent event. Okay, so recall that mutually exclusive basically means that when one happens, the other one cannot happen. So when we use a conditional probability to express that, we can simply say that the probability of A given B have happened is equal to 0. So mutually exclusive. So some example is like the probability of you winning in a gamble and the probability of you losing in a gamble, they are definitely mutually exclusive, because once you win, there is no way you're going to lose, and if you lose, there's no way you're going to win. I mean, of course, real life is not that simple sometimes, because in real life, sometimes you might win and lose both at the same time, but I'm not talking about that. I'm talking something like win and lose is very clearly defined. So you can think of a mutually exclusive event as they are very distinct from each other. When one happens, there is no way the other one is going to happen. So in other words, when we use conditional probability to express that, we simply say that the probability of A given B have happened is equal to 0. So when you find that, we say that A and B, they are both mutually exclusive. Okay, so the other one is independent. Okay, so independent event basically means that when B happens, there is no way, it doesn't really affect the probability of A happening. Okay, so for example, the probability of me reading a book given that it is raining. So when it's raining, it doesn't really affect whether I'm going to read the book or not at home. And of course, this applies to different individuals, because sometimes rain might affect different people's mood, and when they have different mood, it's going to, they are going to like affect whether they are going to read a book or not. But for me, yeah, usually weather don't really affect my mood that much, so usually I'll just go about my daily life, no matter like how the weather is. But so you can see independence. So whether one event affects another event. So we can express that very nicely using conditional probability, where the probability of A given B have happened is just the same as probability of A actually happening. And actually, a pretty nice relation is that mutually exclusive and independent, they are opposite of each other. Because mutually exclusive is like the extreme end. When one happens, it totally excludes the possibility of the other one happening. But for independent event, when one thing happens, it doesn't affect whether the other thing is going to happen or not. And the bad news is, for independent event, you can't really see directly from the Venn diagram. Like, I think this is the reason why conditional probability is like kind of difficult for students to get something, because you can't really see it visually directly from the Venn diagram. You have to kind of use a few lines of reasoning, and you have to use a few like lines of logic to really figure out what it really means. But it's actually not that difficult once you get your head around this. But so if you really like insist on like reading off an independent event from the Venn diagram, it basically says that the area of B compared to S is the same as the area of the intersection compared to the area of B. So they both have the same proportion of area. So okay, so say the whole probability of B takes 20% of the entire area of the sample space, and if A and B, they are independent of each other, it means that where they overlap is also 20% compared to the entire area of B. So it's kind of hard to see from the Venn diagram, and not very useful in practical purposes. So which is why to establish independence, we got to work with the equation saying that the probability of A given B have happened is equal to the probability of A actually happening. Okay, so that's pretty much it for conditional probability. So it just means that the probability of one thing, given that we have the information that we know something else actually happened. So we have to kind of compare, so we have to compare like whether is that going to affect A or not. So that is what conditional probability is all about. So have a think about it and make sure you understand like what exactly is it. Okay, so now moving on to the random variable. Okay, so the random variable is a new addition to year 12 methods in the probability syllabus. So the random variable. Okay, so what I find is a random variable. Many students, they know how to work with it. They know how to calculate it, but not many know exactly what is it. Like, why do we want to do random variable? Like, why is it important? Okay, so that is the purpose of today's lecture. Is I just focus on like why and what of the random variable, not so much on the how do we do the random variable. So for that, I'll leave it to the questions. I'll leave it to the practice exam paper, and then you can work your way up from there. So today's lecture is more on the what and the why. Like why do we do certain things. Okay, so for random variable, okay, so let us begin with the definition first, because usually I think that is the best way to go about in learning math. So we start off with the definition, so we have a clear idea what we are talking about, and then we can work our way from there. Okay, so the definition is this. So basically, the assignment of real numbers to each element in the sample space. So what is a sample space? It's a set of all outcomes, and pretty much we take every possible outcomes and then we assign a number to it. So it's a pretty straightforward definition. But the reason is, why do we want to do that? So the reason is this. It's because in practice, usually the experiments we do don't really give us a number directly in the experiment. Say for example, you flip 3 coins, you're not going to get numbers as outcome. So you have to kind of make sense of certain things. So you want to focus on the certain aspects of the experiment by assigning some meaningful number to the outcome. Say for example, the total number of heads or the total number of tails. Or maybe if you make a game out of flipping the 3 coins, say if you flip 3 coins and then you get 3 heads, you win $10, and then you get 3 tails, you lose $10, and if you get 1 head, you win $5, and so on from here. Okay, so using that example, so it's kind of we assign numbers to them, and then we can apply math to them, because math we have to work with numbers, because if there's no numbers, yeah, it's very difficult to work with math without any numbers. So just a simple example. So imagine flipping 3 coins, and we want to find out the number of tails. Okay, so if we list out all the sample space, so I've included in the diagram above. So S is a sample space, as in the set of all possible outcomes. So the first one, we have 3 heads. So we assign 0 to that. And then for the second one, there's only one tail, so we assign 1 to it. And for the third one, so there is head, tail, head, so there's only 1 tail, so we also assign the same number to it as 1. So we keep assigning the numbers, so we get a nice random variable x, which is 0, 1, 2, and 3. And each one of the numbers have a certain probability of happening. So that is what the random variable is, the assigning of numbers in a sample space, and we end up with a random variable. And the random variable, it can be thought of as a package of numbers, and each numbers have a certain chance of happening. So as compared to the algebraic variable, so say the algebraic variable, it can contain only one number and 100% chance it is that number. But for random variable, it's like, here we have a random variable and it is a package of numbers. And this package of numbers, each one have a certain chance of happening. So this is a difference between the algebraic variable that pretty sure many of you are familiar with, and then the random variable. So it's a very two very different things, but definitely related to each other. Okay, so in order to denote things with random variable, so we say, so the probability of x being a specific number, that one of the number that belongs to in the package, is written as the probability of x is equal to x. So it means that the probability that random variable takes on the specific value. So which means when we do the experiment, this will be the probability of that outcome. And in practice, we not only are interested in a specific value, also very often we're interested in the whole range of values. So we can use inequality to denote that. So the probability of x being between A to B and excluding A to B. So we can visualize the inequality by using the number line very nicely. So as the one I've drawn above, so you can think of a number line from A to B. So we exclude A and B, so any number in between, but we get rid of the A and B. So the number line is a very powerful way for us to visualize like the set of numbers and inequalities. And as we'll see shortly, it's actually a very nice way for us to deal with conditional probability involving the random variable. Okay, so fundamentally speaking, there are 2 different types of random variable. So the first type is the discrete random variable. So where the random variable can only take on a certain value. So for example, say the number of heads. So we can take on 0, 1, 2, 3, depending on how many times you flip the coins. Okay, so you can take on that certain values and nowhere in between. So which is why we call it discrete. So can only take on certain points in the number line. And very often, a discrete random variable involves counting. Like because counting, they are discrete numbers. But this is not the only case. There are many other cases where it can be discrete as well. Okay, so each value have a certain probability of happening, and that is what I've described earlier on as probability of x being equal to x. And the other one is the continuous random variable. Okay, continuous random variable, they are a little bit more difficult to understand. But the basic idea is this. So instead of being discrete values, you can
we are instead interested in like a range in the real numbers. So between A and B, or say between 0 and 1. And between 0 and 1, this random variable can take on any number between 0 and 1. So it could be 0 0.5, 0 0.3, 0 0.4, 0 0.35, 0 0.33, any number in between. And how many numbers are there in the continuous random variable? There's actually infinitely many of them. So this is why we don't really talk about the probability that it is exactly equal to that one specific value, because it is 0. Because finding that one specific number out of infinitely many numbers has a probability of a 0. So which is why we talk about the probability of it being in a certain range. And in that certain range, we find out the probability by using what we call the probability density function. So finding the area underneath the probability density for function graph. Okay, so this lecture, I will not become so much on this one, but it's kind of like there's a very nice link between those two. So whatever operation that you work on discrete case can be brought forward to continuous case. The only difference you need to make is all the sum sigma symbols will be replaced with the integral symbol. So it's a very nice link between those two. Okay, so for year 12 of methods, so you'll be learning, there are some special types of random variable that you learn about. So the first one is the binomial distribution. Okay, so what it is involving like a finite number of trials. So say you flip a coin 10 times, or say you play a game 10 times, and each of the trial have a certain chance of success, so have a certain chance of achieving the outcome that you want, and the probability of success is fixed. Okay, so given the probability of success, so the number of success is given by this nice formula, as in the probability of the number of success is equal to x is equal to n cx. Written over here, I use the matrix notation because it's shorter and more easier to work with. So ncx, as in how many ways you can permute around the success and the failure within the number of trials, and then the probability of success, you raise it to the power of the number of trials, not number of trials, the number of success, and then you multiply by 1 minus p, which is the chance of failure, raised to the power of n minus x, which incidentally is the total number of a failure. Okay, so binomial distribution applies to a very specific situation where it involves like a finite number of trials, each one have a certain chance of success, and they're all independent of each other. So we call it the Bernoulli trials. Okay, so for continuous, we have the normal distribution. So the reason it's called normal is because it's very, very common and appears so much and very, very frequently. So it's given by this formula. Okay, so it's a very complicated looking formula, but don't worry, you are not required to remember this formula, and in practice, nobody actually uses this formula in practice apart from serious mathematicians that want to study the properties of this particular function. Actually, there are a few very nice properties of this function, and it's used a lot in physics, surprisingly. Okay, so just a word of warning is that not all discrete random variables are binomial distribution, and in the same way, not all continuous random variables are normal distribution. So for discrete, you got to be able to discriminate between the different situations. So you can't really, so say you're given a discrete normal random variable, don't just automatically assume it is a binomial distribution. Make sure you check to see that can I apply the non-binomial distribution to that situation. And same thing for continuous random variable as well. Okay, so usually students, they have a little bit difficulty of this is because they only learn one special type of discrete and one special type of a continuous. Usually I find it better if you learn maybe a couple more discrete random variables. There is actually a famous one called hypergeometric and Poisson distribution. And for normal and for continuous, there's a few other ones like exponential distribution and the Boltzmannian distribution. So just a few more different ones, so we can learn that. Also, there are a few other ones, so you got to discriminate different cases and when and where to apply that. So it's important to know when and where to apply that. So whenever you encounter a random variable, see if you can fit into the binomial distribution or the continuous. If not, you have to use some other methods. Right. So now that's pretty much what I want to cover with random variables. So hopefully you get a better understanding what exactly is the random variable, because in math it's not just about going there and solve problems all the time. math is a lot more about understanding what exactly the different things are and where to apply them. So that really helps you a lot in giving you the boost to get to improve and get the high results that that you want. Okay, so now moving on, just combining the two different big things that I talked about today. So conditional probability and random variable. Okay, so how do we evaluate conditional probability involving calculations that have the random variable? Okay, so we use the formula as before, as in the probability of A given B happen is equal to B, the probability of A and B happening. So we have an intersection over here, divided by the probability of B happening. Okay, but the thing is, for random variable, the probability is described in terms of inequalities. They are not really described in terms of sets. So like if that's the case, how can we talk about the intersection between two different inequalities? So it doesn't really quite make sense. Actually, there's a very crucial link over here, is to understand that actually an inequality is actually just a set in disguise. So for example, say x more than or equal to 2 is nothing more than the set of all random variables that has more than or equal to 2. And you can use a number line to kind of illustrate this. We can use an example to demonstrate what I mean by that. So an inequality is just a set of numbers. Okay, so an example. So suppose we have a discrete random variable that has a value from 0 all the way up to 5. So 0, 1, 2, 3, 4, 5. So it could be like flipping 5 coins, or it could be rolling a dice and you subtract 1 from it. Okay, so just the numbers in the random variable, but you're not really given what is the probability for each one of them. But that is not really what I'm interested in for this problem. Okay, so say we want to find out what this probability is. So the probability that x is less than 4, given that x is more than or equal to 2. Okay, so to find it out, we can plug in into the original formula, which is the probability of x less than 4 intersect with the probability of x more than or equal to 2. And of course, at the bottom is just probability of x more than or equal to 2. Finding the probability at the bottom is pretty easy. But the one at the top, we have to establish, okay, what do we mean by x less than 4 intersect with x more than or equal to 2? Okay, and the way to do it, we can use the number line. Actually, you find that the method that I'm about to go through is actually a really powerful way to understand the set of numbers and how do they overlap with each other and find the union and so on. Okay, so we can use the number line and say, okay, so x less than 4 is nothing more than all the numbers that are less than 4. So 4 is excluded, so which means 3, 2, 1, and 0. So any number that is below 3, they are all part of the inequality x is less than 4. So we draw a number line at the top that goes from 3 all the way down to 0. And what about x more than or equal to 2? So for this case, 2 is included. So we start from 2 and then go all the way up to 5. Okay, so where do they intersect? Because it is the intersection, it's where do they overlap with each other? Because remember intersection, the numbers must belong to both of the sets. Okay, so we find that there is an overlap when x is equal to 2 and when x is equal to 3. Okay, so therefore we can say that x less than 4 intersect with x more than or equal to 2 is nothing more than x more than or equal to 2 and less or x less than or equal to 3. So which is 2 and 2 or 3. Be careful with the or and over here, because and or means very different things in mathematics. Okay, so hence we can say this. So we can say that the probability of x less than 4 given that x more than or equal to 2 is equal to be the probability of 2 less than or equal to, so the probability of x more than or equal to 2 or less than or equal to 3. So actually I just say between 2 or 3 and both sides are included. Okay, so the evaluation of this probability, of course, depends on the type of probability distribution we are talking about. If it's binomial, we need to use the binomial CDF function. If it's uniform, and then we can use the uniform from there. Okay, so because we are not really given the probability value, and I'm not that interested in that anyway. I'm just more interested in, okay, how do we find the conditional probability involving the random variable? So you can use a number line to like see visually like how the sets of numbers they overlap with one another and figure out, okay, so that is the intersection between two sets of numbers. Right. Okay, so that's pretty much concludes today what I want to go through today. So just a quick run through on conditional probability and read the random variable and what exactly is it. So before I end things off, of course, I'll give you a couple of tips in order to do better with probability. So the first tip is draw diagrams. I cannot emphasize how powerful this is because when we draw diagrams, we can see visually how things work, and we can have a better idea what we are dealing with. So in probability, there are plenty of diagrams that you can draw. So you can do tree diagrams, you can do Carnot maps, you can do Venn diagrams, you can do or you can really draw the experiment if you want to. So say an experiment involving picking balls from a bag. So you can draw physically a bag and then some balls inside, and then you pick balls from. Or say like rolling 2 dice or flipping 2 coins. So you can actually draw the coins up just to do a rough sketch, and so you can get a better visualization of the problem. And secondly, make sure you understand the problem. So especially for worded problems, so make sure you know what the question is asking for, and make sure you understand every aspect of the problem. Like what are you trying to find? So what are the probability of the certain things happening in there? So why do we use this probability? Why do we use that probability? And so on. So drawing diagram will help you a lot with understanding the problem. And for the second tip, if you're having a bit of trouble with the problem, say you're really struggling with it and can't figure out, definitely try to spend some time to really figure out. Don't just immediately look at a solution. And if you do look at a solution, make sure you analyze the solution and understand why the solution works out this way. So you can try to kind of piece together some puzzles, some puzzle over there. So thirdly, definitely master your CAS calculator, because the probability in year 12 matters. It is pretty heavily calculator based. So you have to know how to do the binomial, how to do the normal, and inverse normal. So what's the difference between the binomial PDF and the binomial CDF? What's the difference between inverse normal and the normal CDF of feature? Okay, so with those two, because ideally whenever you need the calculator, you need to know those functions at your fingertips. So say you want to find out the binomial CDF, so you just go to calculator, immediately fire up the binomial CDF function, get the calculation done fast. Because you don't really want to waste time during the exam, fumbling through a calculator, trying to find out what the certain features are and how to make things work. So your CAS calculator is probably your best friend in the paper 2 in the methods exam. So make sure you know how to use it and master it as much as you can. To understand probability better, actually I find a really good way is, of course, come up with examples on your own. So real life examples. So for example, say you're gambling, so you're playing poker with your friends. So you can try to run through some probabilities from things you have learned. So things, given there is a jack queen on the table, so what's the chance that the next card that is going to throw down is a jack? So things are like that. But things you can be really creative with this one. So things like independent events, like the probability of your dog eating a meal and my cat eating a meal. So that's a pretty fun way to think about probability, and allows you to understand what the different concepts in probability a lot better. And when it comes down to the random variable, and especially for worded problems, have a clear idea what the random variable represent. Because of this one, especially when we work through the calculation, we tend to forget what the random variable actually represent, and we get lost in the problem. So have a clear idea what the random variable represent. And if you define a random variable, define it very clearly. So right off at the start, say, okay, let x be this. So you have a clear idea, okay, so this is what the random variable is. So have a clear idea what it represents. This will save you a lot of heartbreak with the problem. And finally, because we are, for methods exam it's just this Wednesday and Thursday, so we have a short time. So the best way to do it is to jump in there and keep on practicing. So don't bother rereading anything or rereading the textbook. Jump in there, practice, and because probability is best learned by experience. It's best learned when you go in there, try to work out the problems, and try to figure out your way over there. And if you can't figure out, look at solutions, analyze the solution, and make sure you understand why is it being applied. And of course, make sure if you are having trouble or have discussion with your teachers or friends, so that so they can understand what is going on with it. So when it comes out to it, a lot of practice, do a lot of problems, and try to go for understanding a lot deeper. Right. Okay. So I think that concludes today's lecture. So it's just a short and sweet lecture on conditional probability and random variables. So the two bits where usually I find that most students they struggle with in these two particular aspects. of course, in such a short time frame, there's no way for me to cover everything in probability. So for that, I'll leave that to you to work it out yourself. Okay, so like I said, the methods exam is on Wednesday and Thursday. So for those of you guys who are doing the methods exam, pretty sure you are stressing out right now. So don't stress out. Just stay relaxed. Make sure you're well rested. Make sure you're well prepared and go in there and believe in yourself. You will definitely do better than you do. Okay, so I think that concludes today's lecture. So once again, I'm Alfred from Net of Passion. So for those of you guys who are watching this, I want to say a big thank you. And for those of you who missed it, don't worry, it's all recorded. You can view it anytime in the future. So I'll see you again during the next lecture. So definitely stay tuned to my Facebook page for any updates. So I think I'm gonna go now. So have a good evening.